All right, so this is from classwork, and I think this ties in a little bit to what Evan was asking at the very end of yesterday. So let's take a look, and before we do anything, let's talk about what's happening to this function, and then let's see if we can sketch a graph, and then let's see if we can compare that to like what our calculator might do. See how we are. So here we have a function f of x equals negative 1/2 x plus 2 quantity squared minus 1. And here's the claim I'm going to make. I claim that this function is a lot like x squared, except we've changed it a little bit. We actually might call x squared like the parent function, and by parent function it means that we can shift or compress it, but it's still going to look something like x squared. All right, Sam ditched the gum. So someone want to start me off on some of the things that are going on to this x squared function that we're switching around? Monty?
Would you move it over -2?
All right, so the 2 says move to the left 2. Is that okay? Yes or no?
Yeah.
Definitely to the left, not to the right?
Yeah.
And does it feel better with a concrete example like +2? You understand that that means move it to the left 2, as opposed to when we were doing like the minus c or plus c? Yeah, all right. Travis? Okay. Move down 1. As a matter of fact, it seems to me like the 2 and the 1 are actually telling me something about the vertex. Does that sound right? Like, what was the vertex for x squared? Keep going. 0, 0. That vertex. Well, if we move the all the x coordinates to the left 2 and all the y coordinates down 1, if we move them all, that means we have to move the vertex. So you could actually tell me what the vertex is of this new parabola. The x coordinate's going to be, according to Monty, and the y coordinate's going to be, according to Travis, say it loud and proud, -1. All right, so we have an inclination that our vertex is going to be at -2, -1. All right, what do we have? We have some other things going on there. Danny? All right, so that's the minus sign. Reflect across the x-axis. Gesundheit. Are people in agreement?
Yes.
Definitely not. Go ahead. What do we need to change?
X to the y axis.
Y-axis?
Yeah. No, isn't that x-axis though? No, but the a term.
We have a debate.
Function, the whole function, just changing the x. You don't have the negative in front of the x. You have in front of the x.
All right, so the negative is referring to the entire function, the values of this function. It's not referring to the inputs. The negative is affecting the outputs. It's saying everything that you put into here, we'd like you to multiply by -1/2. So that negative is actually going to be affecting the y values. Okay? It would be like saying that f of x is equal to -1/2 g of x plus 2 minus 1, where g is the x squared function. Okay? So we're affecting the y values, and because we're affecting the y values, Danny, we're going to go across the x-axis. All right. That half? Jennifer? Half? Yes, no? All right. And does it make it stretch it horizontally or vertically? Or? Awesome. Good. That's great. Okay. So it's going to be vertically. And Mo, do you want to follow up? Is the 1/2 going to stretch it out, making it taller, or compress it, making it shorter? It's going to compress it because it's for the y value. So Jennifer and Mo put together an argument that this is going to compress a compression of 1/2. It's going to make everything 1/2 as tall. All right. Should we try it?
Don't worry. I have a question.
Go ahead. Hold on, Travis and then Evan. So the exponent is just saying that it's going to be like the function x squared. So that's the parent function. So that's saying whatever you put in here, it's going to look like something squared. So all of this is just a transformation of the parent function x squared. Evan?
So, if you have basically anything in the parentheses that's affecting it horizontally, and it's, I guess you could kind of say like it's kind of like the opposite effect. So like if you have like a divided by 2 or times 1/2, then you actually stretch it, and if you have a negative number, you actually move it to the right.
Yep.
And then outside of it, everything works normally, and it goes right.
Yeah. So there was a teacher a while back who had the students refer to anything that happened in the parentheses as bizarro world. Everything happens not like you'd think. I actually don't like saying that because if you think about the fact that you're affecting the input, like if you know what's being affected, then it makes perfect sense that shifting the x values by subtracting 3 is going to shift the function to the right 3. But if it helps as a way of remembering, the way you categorize it's correct. That it's not intuitive. Inside the parentheses is the opposite of what you may think. Okay? Rafaela? No stupid questions. I think so. Look, we can think about x squared, right? You'd be able to draw that function, and you know that you'd have 0, 0, you'd have 1, 1, you'd have 2, 4, 3, 9. So you could draw that function x squared by hand. Well, if we're going to compress it by 1/2, that just means that the y values are going to be half as big. So instead of 1, 1, it's going to be 1, half. Instead of 2, 4, it's going to be 2, 2. Instead of 3, 9, it's going to be 3, 4.5. So all those y values are going to be half as tall. Now, you're also going to say it, because it also looks like what? Which way? Okay, so Raphael makes a pretty interesting observation, which is true of quadratics. Stretching horizontally actually looks like compressing vertically. They actually have the same visual effect, right? If we squash the parabola and make it shorter, it actually looks like we pulled it out. Okay, so I would agree with that observation, and it's a good and astute observation. But yeah, I think you can compress. I think you can definitely compress a sketch, like you can sketch it. But I think even if you take 1 or 2 points, you could actually really tell me what the coordinates of that point is, or what the coordinates of those points are. Sorry, English. It's tough for we math teachers. That was funny. I didn't mean tiny math teachers. I meant to use English incorrectly. Yeah, I know. That was what was funny about it.
It was here, but does it always work if you multiply what the compression your vertical change, does it always work if you multiply that by the y value?
Say that again.
Like your change is 1/2.
Yep.
So will it always work if you multiply that by the y value? Your change by.
Yes. I think. I don't understand the question. All right, so half is what we're compressing the y values by.
So it's y times 1/2.
Any y value that you get out under the original rule, you now get half the y value out now.
But will it always work if you multiply them together? Because I want to understand the picture. You still don't understand?
No. Like if you had 1/2,
Times y.
like x cubed plus 7x squared plus 13. I don't know what that looks like, but I know that all the y values are half the original functional values. Yeah, no, I totally didn't. I didn't answer your question at all. Hey, try me again, like at another time. I'm sorry. Like maybe when we can sit down and you can sketch a picture or draw what you're saying. I failed miserably, and I apologize. Okay, so let's try the picture. Go ahead, try doing the picture. Give it like some thought, and then maybe we'll do it together. And then we'll maybe check our calculator. Miles, don't even think about it. Put that calculator away.
Don't do it.
So try thinking about it for like 30 seconds without your calculator. Raphael will tell you that it's hard, right? It's hard, right? You want to use your calculator. I know you do. Oh, you stinkers! That's not fair. Oh yeah. Okay. Oh man. All right. So look, I'm going to start by drawing what the original function y equals x squared might look like, and now since we've had some people that already looked at it, we'll do our new function maybe in blue. Okay, so let's see what we need to do. We need to move to the left. Actually, okay, I'm actually going to do it. You might not like this, but that's all right. I'm going to move to the left 2. So that's what that would look like. Okay? And then, you don't like that I didn't draw it correctly? Okay. And then, we need to do 2 more things. We should do, this is Evan's observation. We'll move it down 1, but we should do order of operations. So we should work inside the parentheses first, moving over 2. Then we should do outside multiplication and division. So we should do the multiplication, and then we'll move it down 1. The interesting question is, will it be different or not? I think it might be different if we don't do order of operations.
I feel like, for me at least, it would be easier to do like that way, like do select 2, down 1, and flip it.
Let's see if we get the same thing. All right. Okay, so I need to flip across the x-axis. So I'll stay in blue. It's going to look something like this. And after I flip, I also need to compress. So that's going to flatten it. I should have done different colors for those. That's just bad. So now you can ask about which... All right, so there's the flip. And then... the red is the compression. And now finally I'm ready. I'll do it in like big pink highlighter. Now I'm ready to move it down 1. So I move it down 1. And that's what the function looks like after each one of those steps. The final function is that big pink function. How'd we do? All right. Let's look. So let's take a look at maybe the original function, which would be x squared. Whoops. And now this function, negative 0.5 x times the quantity x plus 2 squared minus 1. So there's the original. Whoops. What did I do wrong? What? Oh, come on. That's crazy. That's crazy. Yeah, I have an extra x in there, right? Let's get rid of that. It was crazy. So there's the original function. And there's that function. I think what I'd like to do is just trace. What's up? Oh, all right. Maybe it's our screen. Oh, you want me to do? Maybe it's because I have a different window. Maybe if I do Zoom standard.
Oh yeah.
Is this better?
Yeah, it does.
Okay. I think it looks a little wider. I think it looks a little darker. Now, here's what I noticed, Elizabeth. If you moved it down, over and then down, let's see. If you moved it down and then you flipped and compressed it, you can't flip over the x-axis anymore. You have to flip along this new shifted down axis. So I think order of operations does make a difference. All right. So Evan, this is your question. When you're doing your transformations, you need to work from the inside of the parentheses, and then do multiplication and division outside, and then addition and subtraction outside the parentheses. All right. Let's see what you remember from Algebra 2. Let's do 23. Where are my Algebra 2 lovers? There are some of you out there, right? Is that you, Keith? That's awesome. Yeah, that sometimes happens. I mean, in general, we like what we're good at, right? Why wouldn't you like what you're good at? All right. Complete to vertex form by completing the square? What does it mean? How do I complete the square? That's crazy talk. I don't think it's factoring.
You find two numbers that zero that do something.
What does even vertex form mean?
Oh, the 2B.
Right, there's 2B.
Oh, man. You're making your algebra teachers cry. They're crying.
Negative 2B.
Oh, you,
Where's your algebra 2 teacher?
You need to,
Jennifer, where's your algebra 2 teacher? I know. Where's he or she? Where is he or she? What school? Yeah, are they crying across the street right now? Yeah, so you all have nothing to complain about, because when did you have it? Eighth grade? Ninth grade? When did you have Algebra 2? Ninth grade. So you have nothing to complain about. No, I didn't. Did I say anything about you not being good at it? I didn't say anything about that. All right. So, vertex form? Go ahead. I'm listening. I'll tell you if you're wrong. I'll tell you if...
why is negative B over 2A?
Yeah?
And the H and K are like...
Yeah, that's the vertex, HK. The vertex of this equation is negative b over 2a. And we should actually look at why they do the same thing. So that's a really great connection to make. The fact that your Algebra 2 teacher probably told you that the vertex, the x-coordinate, was negative b over 2a in this equation. And then in this equation, it was h comma k. All right, so let's take a look, and then maybe we can take a really general equation and complete the square, and then see why it is. All right. Seeing as you did such a great job with vertex form, how do you complete the square? What's that all about? get the 5. We could add 5 to both sides. I'll do it. You don't need to, but I will. And so completing the square means you actually have to make this side a perfect square. And so you need to come up with something that's going to complete that and make it a perfect square. Something that factors perfectly. What do you think we need to do, Sam?
Divide by b by 2.
Nope.
And
Yes, maybe.
And square.
You actually remember a strategy. If you take half of that value and square it, what's half of negative 4? Square it. 4. If you take 4 and add it to this side, watch what happens. Now you can factor. What do you get when you factor? Try again. X minus 2, x minus 2. That's a perfect square. Because that's the same as x minus 2 quantity squared. That's a perfect square. Okay? It's not like two binomials. It's the same binomial twice. Now, here's the thing. You can't just go adding 4 to one side of the equation. That seems a little unfair. So, yeah, you better do the same thing to both sides. So you get y plus 9, y plus 9 over here. And to be honest, Sam, I'm just going to put it back on the other side. Nope. Travis? Yeah.
So when you subtract,
no. I'm adding 4 to this side, so I better add 4 to that side. Now, I will say this. Here's how I remember doing it, and you can tell me, oh, that's crazy, or I'm going to do it the way Sam did it. I remember just doing x squared minus 4x, and then leaving a space, and then subtracting 5, and then saying, oh, I'm going to add 4 to this side.
Why?
What?
I don't get it.
Because
How can you just arbitrarily be like, oh, I'm just going to add 4?
well, not only am I going to add 4, but I'm going to subtract 4. And so if I add 4 and subtract 4, what's that the same as?
0.
No, adding 0. Is adding 0 okay? Yeah. Why did I add 4? Because I was trying to do something. I was trying to make this into x minus 2, x plus or minus something quantity squared.
Yeah.
Well, do you agree that 4 was what worked? Okay. So Sam will tell. I mean, you could just guess, right? And that's going to take a while. Sam actually came up with something. What would you do?
oh, b over 2 squared.
If you take half of this value and square it, that's what you add. So this is b over 2 quantity squared. And that's the trick that will always get you a perfect square.
And half of your b value is the value of x minus.
I don't know what you're saying now. Elizabeth?
I still don't really get it though, like, why do you just like random?
It's totally not random. And I feel like...
oh, I'm just going to add 4 and like, it'll make it perfect.
But it did, didn't it?
But
Now, if your question is, how did you know to do that? What's your question? Why?
Yeah.
I'll tell you why. Because now I have it in vertex form. How's it what? Stop. I'm not just adding 4. If you think that I just added 4, you're not watching or paying attention or listening. I added 4 to both sides. Or, if you want to do it another way, I added 4 and subtracted 4 from the same side. Either way are perfectly algebraically sound. I'm not breaking any rules by I didn't just add something for the sake of adding it. I picked a number that would be a good idea to add because it did what I wanted it to do. And I made up for it by adding it somewhere else or subtracting it from the same side. Right? What did it do? What did adding 4 in this case do? It completed the square. Right? I'm a little surprised now, such that I'm going to ask. How many of you did completing the square last year? Some of you? How do you remember doing it?
I thought completing square was what it ended up being like x squared equals something you brought over and it was like
Completing the square is when you have x squared plus, 9x, and you want to finish off what would make that a perfect square. Well, what would make that a perfect square? Well, you can do some trial and error, but Sam tells you, and I'm hoping that your Algebra 2 teacher told you, you take half of 9, which is 4.5, alright, hold on. Let me pick something a little nicer. You take half of 10, 5, and you square it. And if you add 25, then you make it into x plus 5 times x plus 5, which is a perfect square. Now, you can't just decide to add 25. I agree. You can't just add it, so you either have to subtract it from this side or add it to the other side so that it works out evenly. But we're picking it for a very, very particular reason. We're not just making up a number to add. That number completes it and makes it a perfect square. Why do we want a perfect square? Because we complete the perfect square. We now have the fact that this looks a lot like a parabola. Not only that, it's a parabola that has been moved. How's it been moved? Sam? To the right? 2. And enough out of you? And Max? Down 9. So this tells me it's a parabola that's been moved to the right 2, down 9. That's where the vertex is. This form is screaming to you. The vertex is 2, negative 9. This form's not screaming to you. It does scream, the vertex happens at negative b over 2a. Negative 4, the opposite's 4, divided by 2. This tells you that the x-coordinate's 2. So they agree. All right, Max, then Elizabeth?
I just have a question about how you got negative 9. Since you found that it was 4, was it y plus 4, and then you missed it? It's like, 4.
Over here?
Yeah, I'm just...
So I added 4 on this side, and you know what? Here's the problem. I should have done this. I'm sorry. Maybe this was part of the confusion. If I just add 4 to that side, I have to add 4 to the other side. And so 5 plus 4 is 9, and then I subtracted it from both sides. So I sort of did over on one side, then brought it back. Elizabeth and then Evan.
So basically, you're saying that y equals x minus 2 squared minus 9 is the same thing as y equals x squared minus 4x minus 5.
Yeah, exactly. Not only am I saying it, but we proved through completing the square that these two things are the same equation, just said differently. And saying equations differently can sometimes help us. In this case, putting it in vertex form is screaming at you that the vertex is... He's screaming at you that the vertex is 2, negative 9. This form is not necessarily screaming at you, although you could probably figure out the vertex.
Like if you have like a linear equation and point split, you convert it to point split.
That is a perfect analogy. Okay, so Elizabeth is drawing sort of analogies to if you had y minus y1 equals m times x minus x1 versus y equals mx plus b. One of these equations is really good if you want to know what the y-intercept is. The other equation is really good if you want to know what a point is. Right? So, like, they both tell us different things in different ways, but they represent the same equation. Thanks. I think that was a great clarifying concept, and, like, if I had to start the lesson again or start this problem again, that's what I might say. I might say, hey, you know how you look at linear equations differently? You look at, exponential equations, quadratic equations differently as well. And, well, alright, no, not that. Alright, fine. what should we do? Sketch. I think maybe. All right. Well, no, hold on. All right, let's try to do 24. Let's try to do a couple of these problems, and then I think what I'd like to do at some time is prove to you completing the square in the quadratic formula. But I think you guys can probably wait on some proof, and we could probably get a little more out of some practice.
Are we going to go over homework and everything?
Probably.
Another day.
I think so. My anticipation was we were going to feel a little bit better about completing the square. It was going to be like, oh yeah, you reminded me how to do it. I remember that. We did it all. And it's not quite what happened. All right, so I need to find the equations of these parabolas. And the first one is actually screaming to us a particular form of writing a parabola. So I'll give you either have this form, which is standard form, or you have this form, which is vertex form. And I need to say this because sometimes it's not clear. This A and this A are different A's. Because they're different formulas and equations, they're different values, and I don't know why we just didn't pick something differently. What's it screaming to you, Travis? It is. It's totally screaming to you vertex form. So, Travis, call on someone to pick this parabola and tell us what to plug in where.
Okay, I'm not quite sure, but I said 1/2.
I don't want that yet.
Oh, okay. Plug in where?
I was hoping like
Okay.
those.
Well, I said 2.
So x minus 2 or plus 2?
Plus 2.
Plus 2. Why plus 2, everyone?
To the left.
All right, it's to the left. And then plus 5. Now, we still have this A. So the vertex helps us find part of the vertex form of a parabola, but there's still an A value. Now, sometimes the A value is 1, and we don't have to worry about it. Other times it's not. As a matter of fact, doesn't this parabola look like it's squished or flattened or something? Raphael, get your head up. Come on. Give her a kick or something. Come on. Head up. There we go. Usually to find A, the most convenient thing is to pick another point. All right? So, all right. So that point is 60 or 06? 06. If we know that 06 is also a point on the graph, I can plug that in for y and for x. Do you see how I plugged the y in for the y and the x in for the x? And now I get 6 equals 2a plus 5. So let's see. 1 equals 2a, or a equals 1/2. So now I can go back to this equation and write y equals 1/2 x plus 2 plus 5. And that's the equation of that parabola. Good.
So you do the opposite while going into the parentheses as well as going out. That makes sense.
It doesn't. So I'm going to say yes?
Yeah.
Okay, fine. All right, what about this parabola? Is this screaming to you vertex form?
No.
I don't think so. I think this is actually screaming to you factored form. I think this is screaming to you something like this. Hold on. X minus something times x minus something. Help me fill in what the minuses would be, and then we won't worry about a, but x minus negative 1 times x minus 3. That would be factored form, right? If the roots are 3, then x minus 3 is a factor. If the root is negative 1, then x minus negative... Say again? That's 5? Holy cow. 5 it is. All right. Have a terrific Tuesday. Good luck at all the games this afternoon.